tonight we'll look at section 4.6, which is graphs of other trig functions. So I'm going to begin by talking about the tangent, pardon me, and the cotangent function. Okay. Now, tangent and cotangent, a little different than cosine and sine. Their period is pi. So not 2 pi, their general period is pi. They have vertical asymptotes as well. And the x-intercepts occur midway. Okay, so I'm going to show you both of those. I'm going to address this as I go down. So first I want to talk about the tangent graph. Okay, and I apologize, I'm at lunch, so, well, I'm at my planning, which is during lunch. Alright, so first let's look at the tangent curve. Okay, so this curve repeats itself every pi interval. Now, he's got these vertical limitations again. Now, his are going to be at pi over 2 intervals. Okay? Okay, and then I could go negative pi, positive pi. Now again, this is the general curve. So you have to understand that it's not going to hang on, let me grab my pen. It's not going to, we can shift it back and forth. So the typical curve for tangent will, sorry, I seem like I'm having issues. It goes through 0, 0. At pi over 4 we would be at negative 1. At pi over 4 we'd be at 1. You get a curve that looks something like that. Okay? So here is my pi interval, and then tangent is going to go in there. And so, let me fix this. So this is pi over 4, pi over 2, 3 pi over 4, pi. So let me move pi here, and this would be 3 pi over 2. Okay? So that's what tangent does. It keeps going in that same cycle. Okay? And these vertical limitations would happen every pi. Alright, let's look at cotangent. Alright, cotangent has limitations. The x-axis is actually 1. So this is from 0 to negative pi, so it would be pi over 2, and this would be positive pi over 2. Okay? Again, those are its x-intercepts. Now, where tangent starts low and goes high, cotangent starts high and goes low. Okay? So the difference is tangent starts low, goes high, cotangent starts high, goes low. And also where your asymptote sits. Okay, so here they're at pi over 2 and negative pi over 2. Here they're at 0 and pi. Okay? Alright, so now let me teach you how to graph these functions. So we're going to graph these slightly different than we did sine and cosine. So to graph the tangent and cotangent. Step 1. You're going to find those vertical limitations by solving. If you have tangent, you're going to say negative 2 pi is less than, right? Because pi over 2 is where the typical curve begins. That's where its limitations are. And in the middle, you're going to put bx minus c, and then you're going to solve for it. So the cotangent again, bx minus c is in the middle, but your cotangent's typical limitations are 0 and pi. Alright, so that's step 1. Step 2, identify it will always be midway between. Okay, last step. Find the point on the graph, 1/4 and 3/4 of the way. These occur at negative a and a, which remember a is in sine and cosine your amplitude. Oh, I lied. There was a step 4. I didn't see it until I turned my paper. Alright, so step 4 is use steps 1 through 3 to graph one full period. Add additional periods if needed. Let's put if desired. Okay, so let's see how we're going to put this all together now. Alright, I'm going to graph at least one tangent and one cotangent, I hope, before I run out of time. And then in class tomorrow, I'm going to add the cosecant and secant. Alright, so example 1. Graph 2 full periods. Which means I'm forcing you to graph 2. Y equals 3 tangent to x. So the first thing I want to determine is, which trig function am I? So I'm graphing tangent. So in step 1, what goes at either side when I graph the tangent function? Negative pi over 2 and positive pi over 2. And then it says in here to put bx minus c. That's going to be what's here. So I'm going to put 2x in the center. Now what we're going to do is go ahead and solve. So do you agree to get x by itself? I'm going to divide by 2. Divide the middle by 2, I have to come over here and divide each of these by 2. So I end up getting negative pi over 4 and positive pi over 4. Okay, so now I'm going to do step 3 and step 4 simultaneously on the graph. So let's go ahead and you have your graph. And it's okay, we're going to spread this out a little bit so you can see. This is negative pi over 4 and pi over 4. Alright, step 2 says identify the x-intercept halfway between these two verticals. So, what is halfway between negative pi over 4 and pi over 4? Do you agree that is 0? Now what I want you to do is I want you to then subdivide each of these. Okay, again, if you need to, you can use your calculator. You're saying what's half of a fourth? So if you take a fourth and cut it in half, you would get an eighth. Now, look here in front of the function, you have a 3. That means that you're going to go up 3 and down 3. So when you're at negative pi over 8, you'll be here at negative 3. And when you're at positive pi over 8, you'll be at positive 3. And so now this is my curve, something like that. Again, my curves are not necessarily the prettiest. Okay? Let's do it all again. We're going to take 3/4 and we're going to add pi to it. Okay, so I'm going to graph another period of it. So again, the cycle for tangent is pi, right? That's his period. So what is 1/4 plus a pi? Do you agree that that is? So you have, here you're at a fourth, you go another pi, you would be at 5 pi over 4. Okay, what is halfway between 5/4 and 1/4? Well, 5/4 and 1/4 is 6/4, which is 3/2. Now, again, if the fractions are bothering you guys, right, if you're going nuts, then by all means, go ahead and type it in your calculator. Now, once you've subdivided it, I'm okay if you don't have to do it again, okay? I just need to at least know what that center point is. Okay? You ready? Let's try another one. Let's say I want you to graph the tangent of x minus pi over 2. Okay, so first step, determine whether it's tangent or cotangent so that you know where your limitations that you're in should be. Okay, so tangent goes from negative pi over 2 to positive pi over 2. Now, in here, I'm going to put whatever is following the tangent function. So, x minus pi over 2. Alright, I need to get x by itself. So, do you agree? I'm going to add pi over 2. So, I get 0 is less than x is less than 1/2 plus 1/2 is 1/2. Okay? Alright, let's go ahead and graph it. Zero pi. Whoops. Great day throwing pins everywhere. So there's one vertical limitation. Here's the other. Okay? At this point, I need you to take between 0 and pi and divide it by 2. So 0 and 1, halfway between it is 1/2, so pi over 2. That's where my x-intercept is. Now I need you to subdivide here. So between 0 and 1/2 is 1/4. And between 1/2 and 1/2 is 3/4. Now, this time, do you agree that in front of tangent is a 1? So when I'm at pi over 4, I'll be at -1, and when I'm at 3 pi over 4, I'll be at +1. And there's my curve. Now over here, I simply need you to say, my period for tangent is pi. So what is pi plus pi? 2 pi. And now I just need you to get that halfway point. What's halfway between 1 and 2? 1½ which we're going to write as 3/2. So when you get to the second curve, I'm okay if you just find that halfway point again. And there it would be. Let me go ahead and draw in that other dashed line. Alright, we're good? So that is your tangent curve. Let's end the video by looking at what cotangent does. So cotangent is going to be very similar to the process you just had for tangent. It's just your limits are going to change. So I want 1/2 the cotangent of pi over 2x. Now, for cotangent, what are your limitations? 0 and pi. I'm going to take what is behind my cotangent function. So I have pi over 2x. I need to get x by himself. So do you agree that I'm going to multiply, let's see, first I'm going to go ahead and multiply by 2. So I'm going to multiply every term by 2, because that will clear my denominator. So I get 0 is less than pi x, which is less than 2 pi. But x is not alone. So now I'm going to divide by pi. So I get 0 is less than x is less than 2. Alright, well this is easy. At least I don't have pi's to deal with. Okay, so let's go ahead and graph it. Now I know you're saying, wait a minute, I thought the period was 1. What happened is this, remember, is going to horizontally stretch it. Okay, so I have 0 and 2. So it's going to take that long for my cycle to complete. That's going to become important when I draw my next cycle. Alright, so halfway between 0 and 2 is 1. Now mark your other point. Halfway between 0 and 1 is 1/2, and halfway between 1 and 2 is 3/2. Look in front of your function, the 1/2, that's how, it's not really the amplitude, tangent doesn't have that, but it's going to help you out when you go to graph these. Okay, this is my x-intercept. Now remember, cotangent goes high to low. So at 1/2 he'll be at 1/2, and at 3/2 he'll be at -1/2. Now I'm going to do one more. I need to repeat this. So I'm at 2 is what the interval took me. So do you agree that my next interval would be at 4? Halfway between 2 and 4 is 3. And now draw your other curve. Okay, and that concludes this video. So I'm going to give you one to practice, and then we'll work on this a little bit more tomorrow. You guys have a great evening.